Hello, College Algebra, and this is the video lesson over 1.4, which is going to cover imaginary numbers. So to start off, what imaginary number is, or in this case, what does I represent? The imaginary number I is the same thing as the square root of -1. And if you try plugging this into your calculator, you end up getting a domain error. So this lesson is going to cover how to deal with imaginary numbers when solving problems. And just another heads up, it's not just I we're going to be dealing with, but also I raised to certain powers. Like, for example, I squared is actually the same thing as -1, and that's going to be a big help later on in today's lesson. So now with a little review, something you might have learned in Algebra 2. So let's say you have I, or I to the first, and then I squared, I cubed, and then I to the fourth. Back in Algebra 2, I told you that each one of these represented a specific answer. Like for I to the 1, that was just I. I squared, as you saw in the previous slide, is the same thing as -1. I cubed is actually the same thing as just a -I. But then I to the fourth becomes +1. So if you look at the pattern, I, -1, -I, 1. Or in Algebra 2, I like to call this little pattern the I1, I1 pattern. So in other words, I1, I1, I won. If you remember that little phrase, memorizing these 4 parts will be a piece of cake. The only thing you'll have to specifically remember is that the 2 middle numbers have a negative, while the outside parts are positive. So again, I won with the negatives in the middle. You remember that? It's going to be a piece of cake. And of course, memorizing these 4 will take care of all the other powers. For example, let's say we just memorized the first 4. So in other words, I won. But you just have to remember to make the middle ones negative. That takes care of the first 4. If you move on to the next powers, 5, 6, 7, and 8, if you remember from Algebra 2, the pattern actually repeats. Well, in other words, you'll still have I won, with the negatives in the middle. Same thing for the next 4. I won, with the negatives in the middle. Same thing with the next 3. I won, with the negatives in the middle. So just remembering that pattern, I won, with the negatives in the middle, that'll take care of any power that you're thinking of. And that will be a big help in some examples that you'll come across in the online homework. So let's say on the online homework, let's say it gives you I to the 10th. And you need to figure out what its simplified answer is. Well, one way of doing it is you can use the I won pattern. Or in this case, if you rewrite the numbers, I won. Then make the negatives make the middle ones negative. Then literally you can just count. Like this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Which means I the 10th has to be -1. Done. Piece of cake. Now the next one, if you look over to I the 32, this one, well, you can still use the I won pattern with the negatives in the middle, and you can count all the way up to 32 if you want to. But sometimes people don't like to count that high. And if you don't like counting that high, there is a recommendation. If you go back to the previous slide, I want you to take a look at the bottom parts. I to the 4th, I to the 8th, I to the 12th, I to the 16th. Notice when you look at all those powers, 4, 8, 12, and 16, notice how they're all multiples of 4. Anytime you have a power that's a multiple of 4, your answer is going to be equal to 1. So let's take a look at that answer, or that previous example, I to the 32. And let's think, is 32 a multiple of 4? And the way you can figure that out is, why don't we divide it? 32 divided by 4, you put that in your calculator, gives you 8. So in other words, 32 is a multiple of 4. And any multiple of 4 is immediately going to equal positive 1. So that was pretty easy. Any power that's a multiple of 4 instantly becomes 1. Easy peasy. But now moving on to the last two. So I to the power of 115. Oh boy. Well, if you really want to do the I1 procedure and count 1, 2, 3, 4, 5, 6, 7, 8, all the way to 115, you can certainly go ahead. That is totally up to you. If you don't have the patience for that, I would recommend trying to use the multiple of 4 technique. So in other words, let's take 115 divided by 4, and let's see if that divides evenly. So 115 divided by 4, and that gives us 28.75. Yeah, 115 is not going to be a multiple of 4. So then what do we do now? How can we figure out this problem without having to count the I1 all the way to 115? Well, my recommendation is, why don't we try one less than 115? Or let's go 114. Let's try dividing that by 4. And that gives us 28.5. Shoot, that did not work. Well, let's try taking one more away. So instead of 114, let's try 113 and divide that by 4. 113 divided by 4 gives me 28.25. Again, not quite right. But let me try one more time. I'll take one more away. So then instead of 113, I have 112. And let's divide that by 4. So 112 divided by 4 gives me 28. There we go. So 112 divided by 4 would be 28. So this would be a multiple of 4. So using this knowledge, what I'm going to do is go back to my original answer, or my original problem, and I'm going to split it. The first thing I'm going to split it into is I to the power of 112, using 112 because it's a multiple of 4. But then the second power, with this case, we need this power to add to give us 115. So this power has to be 3. That way, 112 plus 3 gives us 115. So now I've taken 115 and I've split it to these two i's. And now that I've done that, I can solve each one separately. So I to the 12th, we just saw was a multiple of 4, and any multiple of 4 instantly becomes 1. And then second, we have I cubed, which according to the I1 pattern, that's the same thing as -1. So in other words, we have just now simplified the problem to 1 times I. which means our final answer is going to be negative I. So that would be my recommendation for taking care of those problems when the power is a really big power like 115. Let's try it again with the final example where you have I to the power of 129. Again, you could count the I1 if you want to until you get to 129. But if you'd rather find the quick route, let's first just take 129 and see if it's a multiple of 4. So 129 divided by 4 gives us 32.25. So that would not work. Now let's try taking 1 away. So instead of 129, let's try 128. 128 divided by 4 gives me 32. Bingo. Which means 128 would be a multiple of 4. So let's use that number. So with that said, I'm going to take 129 and I'm going to split it into 2 different i's. The first I, I'm going to have a power of 128. And I got that from over here. The second I has to have a power that will add to 129, which in this case would be 1. So therefore, 128 plus 1 gives you 129. And now that we've done that, now you can just simplify each part. I to the 128, as you saw, was a multiple of 4, and any multiple of 4 would just become 1. And then I to the 1, well, according to the I1 pattern, that's just going to be I. So therefore, now you just have 1 times I, which just simplifies to I as your final answer. So in other words, when you have problems like these on the online homework, you can either count using the I1, or you can use this procedure to find a multiple of 4 and then break it down to find your answer in a much quicker method. Each procedure is available to you. Use whichever one you like. But now moving on to some different examples. Let's say you have these examples, square root of negative 16, square root of 9, so on and so forth. And if you try plugging these into your calculator, you're going to get a domain error. So sadly, we cannot use our calculators in this case. We have to do something different. And what we're going to do is we're going to split this radical. Split it specifically so that the first root is negative 1, and then the second root is 16. The reason I split it is because, if you remember from the very first slide, I is the same thing as negative 1. So making this negative 1, I can actually convert that to an I. And then square root of 16, that's a perfect root. That just becomes 4. So for your final answer, you just got to do I times 4, which just becomes 4I. And that's your final answer. Easy as that. Now let's take a look at the one underneath it, where we have a negative on the outside and then a negative on the inside. The negative on the outside, give me a moment. The negative on the outside, we can actually leave alone. The negative on the inside, that gives us an imaginary number, and we need to get that imaginary number out. So to do that, I'm going to split this to negative 1 and square root of 81. So then when I do that, you still bring down the outside I. This square root just becomes the imaginary number I, and the square root of 81 is a perfect root, which becomes 9. So you got a negative combined with an I combined with a 9, which becomes negative 9I. Easy peasy. So in other words, if there's a negative in the front, just ignore it and then just put it in the front as your final answer. So with that said, now that you've taken a look at these two examples, try the two on the right on your own. Pause the video, take a shot at these two problems and then resume the video so that you can check your answers. Go ahead and do that now. Okay, you should have resumed the video by now and have tried the right two examples. So square root of 9, or I should say the square root of negative 9. In this case, you will have to simplify it. So you split it into negative 1 and then 9, and then simplify each one separately. Square root of 1 becomes I. Square root of 9 is a perfect root, which becomes 3. So that's just 3 times I, or 3I. Moving on to the next example. First, let's bring down the negative, and then we can split the radical. So the first radical will get negative 1. The second radical will get 289. And then simplifying each part from there. First, bring down the outside negative. Square root of negative 1, that's just I. And then the square root of 289 turns out to be 17. So the negative times I times 17 will just become negative 17I. So those examples are pretty straightforward, fairly easy. But now let's take it up a notch. Moving on to the next examples. Let's say I have the square root of negative 8, and I need to simplify that one. So if I go with the same procedure I did, I'll go square root of negative 1, and then square root of 8. And then the square root of 1 would become I. But if you take a look at the square root of 8, that's not a perfect root. That turns out to be a decimal if you plug it in your calculator. And sadly, we can't just leave the final answer as I radical 8. The Hawks program won't accept it like that. So we got to do something a little bit different. And what we're going to have to end up doing is we're going to take the square root of 8 and we're going to have to split it. And my recommendation for splitting it is off to the side, I'll first make a list of all the squares, and specifically the square roots examples that help us find perfect squares. So 1 squared, 2 squared, 3 squared, which is 9, 4 squared, which is 16, 5 squared, which is 25, 6 squared, which is 36, 7 squared, which is 49. And I'll keep it right there. So, my recommendation is take a look at this list and find a number that's a multiple of 8. And my recommendation is start at the bottom. So let's start at the bottom. 49 won't work, 36 won't work, no, 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 bingo. The square root of the 4 is a multiple of 8. So in other words, I'm going to use 4 when I split it. And therefore, when I do that, the I becomes I, square root of 4, it just becomes 2, and then the leftover root 2 stays as it is. So now you just have I times 2 times the square root of 2, which just becomes 2I root 2. And there you go. So when you're breaking these down, or when you're trying to simplify these answers, please use this list. It is a big help. But now let's take a look at the second example, the negative root of negative 80. So let's first, as we know before, we'll drop the negative on the outside, and then let's split the 80. We'll have a negative 1, and then we'll have a negative 80. And then when you simplify that, negative goes down, square root of 1 becomes I, and square root of 80, sadly, is not a perfect root. So we're going to have to split that one. And when I split it, I'm going to try and find a number from my list that's a multiple of 80. And I'll start from the bottom. Sadly, 49 is not a multiple of 80. 36 is not a multiple of 80. 25 is not a multiple of 80. 16. Is 16 a multiple of 80? Let's take a look. 80 divided by 16. Oh, sure enough. 16 times 5 gives you 80. So let's go ahead and use square root of 16 to simplify this problem. So continuing forward, drop the negative, drop the I, square root of 16 becomes 4, and then the root 5 is left over. So there you go. There's your parts of your answer, which if you bring together becomes negative 4 of I, root 5. And there you go. So now, try the last two on your own. Try square root of negative 108, and then try the negative square root of negative 27. Go ahead and pause the video, take a shot at those, and when you're done, resume the video to check your answers. Go ahead and do that now. All right, you should have tried these by now, resumed the video. So now let's check our work. Just going to draw a line here to separate the two parts. So first, let's split this one. Square root of 1, or negative 1, square root of 108. So square root of 1 will just become I, but the 108 is not a perfect root, so we're going to have to split that one. And if you start from the bottom and work your way up, 49 won't work. 36 should. So then 108 and 36. 36 would have to be in this root. And then the leftover one has to be 3, because 36 times 3 will give you 108. And now let's simplify from there. This becomes I, this becomes 6. This is just leftover root 3. Combine those parts and you get, as your final answer, 6I root 3. Bada bing, bada boom. Now let's try the last one real quick. Okay, I'm going to erase this just to make room. So to start off, drop down the outside negative. Then this has to split into negative 1 and 27. The negative still drops. Give me a sec. The square root of negative 1 becomes I, and the 27 is going to have to split. And if you use the same routine, you should see that this will have to split into root 9 and root 3. Then if you simplify from there, this becomes negative, or that stays negative, this stays I, square root of 9 becomes 3, and that just stays root 3. Then combine all your answers to get negative 3I, and then the root at the back. And there you go. To be honest, I feel like this is probably going to be the most challenging part of the online homework. If you can master this stuff, then the rest of the lesson is going to be a piece of cake. But now moving on to a couple other examples. So let's say you have two negative roots and you have to multiply them. Now, I do need to give you a warning real quick. I've had a lot of students say, oh, I can just multiply the negative 8 and the negative 2 to get positive 16, and then that just becomes 4. Sadly, that is not the case. That is not how it works. What we have to do instead is first rewrite negative 8 and negative 2 as imaginary numbers. Or in other words, you first got to make square root of negative 8 as I root 8. and then the second one as I root 2. And then once you've done that, now you can multiply. And specifically, you first have to multiply the two i's together. And I times I is I squared. Then you can multiply the roots together. Root 8 times root 12, which will give you 16. And then from there, you can simplify. The I squared, as you know from our previous example, that's the same thing as -1. And then the square root of 16 just becomes +4. And then -1 times 4 gives you -4 as your final answer. The second example works in a very similar way. Before you can do any multiplication, you have to take the two roots and rewrite them with i's. And then you multiply them together. The two i's will give you I squared. Root 98 and root 2 should give you root 196. And then from there, simplify the two parts. The I squared, same thing as -1. The square root of 196, if you plug that in your calculator, gives you 14. And then -1 times 14 is -14. So that, again, that's my recommendation. Make sure you change this into I form and then multiply. And if you do that, solving these will be a piece of cake. And with that, I think we are about halfway done. All right, the rest of the stuff should be easy on from here. So now, part 2. Let's say I have two parts. I have a real part and I have an imaginary part. If I were to add them together, this would be called a complex number. And the way that it works is because since we can't add real numbers and imaginary numbers together, we have to keep them as separate parts. And this is something that's going to be crucial to know when we start adding, subtracting, multiplying, and dividing imaginary numbers. So let's start with adding, subtracting complex or imaginary numbers. Just like zebras stay with zebras and giraffes stay with giraffes, you can only add and subtract reals to reals and imaginary to imaginary. So in other words, say I got 11 minus 2i and 9 minus 7i, and I have to add them together. And the way it's going to work is that you first got to take the two real numbers and add them together. 11 plus 9 to give you 20. And then you do the same thing with the imaginary parts, the -2 and the -7. -2i and -7i will combine to give you -9i. And once you've done that, you're done. That's your answer. Easy enough. It's basically the same thing with subtraction. But my advice, if you have a subtraction example, I strongly encourage you change that minus to a plus and then change the signs of the second expression. Then you can start adding things together. Or in other words, add the -2 and the +3. That will give you 1. Then you can add the +3i and the -3i. And if you'll notice, the positive and the negative just cancel out. So then you're just left with 1. Nice. And then the last example, let me scroll down for a second. Notice how this one's a little bit different because it has an I squared. And sadly, we cannot leave this alone. The I squared, you have to rewrite that as a -1. And you have to do that before you add anything together. So in other words, this is actually 8 times -1, which will become -8, and then minus 9i. And then once you've taken care of that I squared, then you can start combining like terms. So then the -8 and the 3, combine those to get -5, and then combine the imaginary numbers. -9 and 3 will combine to give you -6i. And then that would be your final answer. So with these examples, anytime you see an I squared, please change it back to a -1. It will make your solving much easier. So adding and subtracting, piece of cake. Now moving on to multiplying. Multiplying complex numbers. And nothing much new here. You really just have to FOIL, or in other words, first, outer, inner, last. Then combine like terms and simplify, and then you're done. So let's go ahead and try that with the first example. Let's FOIL the terms. So first term should give you 64. Outside terms should give you 72i. Inside terms will give you -72i. And then the last terms will give you -81. And then we're multiplying two i's, which should actually make that I squared. All right, we've done first, outer, inner, last. Now it's time to combine like terms and simplify. Looks like nothing can combine with a 64. The two i's can combine, and they'll cancel out. The -81i squared, look out. The I squared is the same thing as -1. So this is actually, let me fix that. So this actually becomes -81 times -1, which a negative times a negative becomes +81. So then for our final answer, we have 64 plus 81, which just becomes 145 as your final answer. So again, not anything too different. Why don't you take a moment to try the second one on your own? Pause the video, try it, and then resume the video to check your work. Do that now. All right, you should have tried it and resumed the video by now. So first, if we FOIL, the first term should give you -6. The outside term should give you 9i. Inside term should give you -4i. And then the last term should give you 6. And then I times I, which is I squared. Okay, FOILing is done. Now let's combine like terms. So far, nothing combines with a -6. Add the 9 and the -4i to give you +5i. The 6i squared, remember the I squared becomes -1. So this is actually 6 times -1, which becomes -6. Now we can combine our terms a little bit further. -6 and -6 give you -12. And then add the 5i. And that's your final answer. Just like that. Easy peasy stuff. Again, nothing really new. So now we've added, subtracted, and multiplied. Now it's time to divide. Yeah. Dividing complex numbers. I got some good news and I got some bad news. The good news is you don't actually have to divide. That's nice. But the bad news is you have to simplify so that no imaginary number is in the denominator. Or more specifically, we don't want I in the bottom of a fraction. Anytime that happens, we need to fix that. So in order to do that, to fix it so that there's no I in the bottom, we need the complex conjugate. This may be new for some of you. The definition of a complex conjugate, is basically, let's say you have a complex number, 2 plus 3i. And what if instead of a plus, you changed it so that it was a minus? Anytime you do that, you have just made a complex conjugate. Basically, anytime you have a sign and you change it to its opposite, that's the conjugate. Easy enough, but why is the conjugate so important? How does the conjugate help us? Well, it turns out the conjugate has a way of making imaginary numbers real. Let me show you. So let's pretend I have 2 plus 3i. And right now, it's an imaginary number because it has I. Just like Pinocchio, he's not technically a real boy yet when he's a puppet. He's kind of an imaginary boy, sort of. He's not completely real yet. But let's pretend that the fairy godmother is going to work her magic, and she's going to use the complex conjugate. So in other words, give me a second. Let's say I have 2 plus 3i, and I'm going to multiply it by the magical conjugate. So then let's see what happens when I FOIL it. So if I FOIL, I'm going to get first term is 4, outside term is negative 6i, inside term is 6i, and the last term is negative 9i squared. And just like before, let's combine the like terms. 4 can't combine yet. The 6 and the negative 6 cancel. The I squared becomes negative 1. So negative 9 times negative 1 gives you positive 9. And then 4 plus 9 gives you your final answer of 13. And just like that, look at that. 13 is a real number. It's no longer imaginary. I'm a real number. I'm a real boy. Oh my gosh, some of you are probably laughing your butts off from hearing me say that. But it gets the point across. If you start with an imaginary number, multiply by the conjugate, and you'll get a real number every time. So that's how Pinocchio, in terms of math, starts off as a puppet and becomes real. So now that you know the importance of a conjugate, let's use it with an actual example. So dividing complex numbers, we need to simplify this expression. And as you can see, we have an I in the bottom. We do not need any I's in the bottom, or we don't need an I in the denominator. And the way to get rid of it is I'm going to take 3 plus I, and I'm going to multiply by its conjugate. Or I'm going to change that plus to a minus. However, if I multiply by a conjugate on bottom, I'm going to have to do the same thing on top, just to be fair. So now, let's work the magic of a conjugate so that the bottom is now real. So let's FOIL the bottom. So FOIL. First term should give you 9. Outside term should give you negative 3i. Inside term should give you 3i. And then the last term, I times negative I, will give you negative I squared. And then if you do the same thing on top, FOIL the 2i with the conjugate 3 minus I. First term should give you 6. Outside term should give you negative 2i. Inside should give you 3i. And then the last term should give you negative I squared. Okay. So now we got to simplify top and bottom, combine like terms. First, going to start with the bottom part. So in other words, first we have the 9. The negative 3 on the 3i will cancel. And then the I squared, that's negative 1. So you got a minus negative 1, which becomes plus a positive 1 on bottom. And that should give you a 10 at the end. But now, let's take care of the top. First, I got a 6. The negative 2i and the 3i will combine to give you just 1i, or I. And the negative I squared, that's negative 1, or minus a negative plus positive. So that becomes plus 1. Now we can simplify from here. On top, 6 plus 1 is 7. And then you just have the 1i, which you can just write as I, same thing. And then on bottom, 9 plus 1 is 10. And look at that. All the i's are gone. And once all the i's are gone on bottom, then that's your final answer. 7 plus I all over 10. Done. Oh, give me a second. My phone just went off. Sorry about that. Moving on. So, conjugates. They're your best friend. They will help you with these examples. Try another example. 4 plus 3i. We have an I in the bottom. We don't want that. So we got to simplify. And the way that we're going to do that is we're going to multiply top and bottom by the conjugate of the bottom. So 4 minus 3i. 4 minus 3i. And let's go ahead and do that. I'm going to go ahead and do it over here. Going to go ahead and first FOIL the bottom. So first you should get 16 outside, negative 12i. Inside, positive 12i. And then the last term should give you negative 9i squared. And then on top, I'm actually not going to FOIL that or distribute that. I'm going to keep it like that for now. Trust me, you'll see why in a second. So now moving on, I'm going to go ahead and take care of the bottom. 16, just keep it 16 for now. The negative 12 and positive 12 will cancel. The I squared becomes negative 1. So negative 1 times negative 9 on bottom becomes positive 9. And then on top, I still have 25. On top, I still have 25 times 4 minus 3i. And then if you simplify the bottom, 16 plus 9 is 25. And on top, you got 25, 4 minus 3i. Look at that. 25 on bottom, 25 on top. I can just cancel those out. And all I'm left with is 4 minus 3i. Look at that. There's not even a bottom. There's no I on bottom. I think we're done. 4 minus 3i, your final answer. Done. I think you like that one. That one was pretty sweet. Use that as a reference. Basically, anytime the top is just a number, don't distribute. See if it'll cancel out first, and then go from there. And now one more slide, and then we'll be done. Let's say you have an imaginary number, and it's raised to a power. There is a do and a don't. I'm going to first tell you the don't. Do not distribute the power to the complex number. Or in other words, I've seen students distribute the power like this. So then 2 squared becomes 4, and then the squared becomes negative 9i squared. That is not how you do it. That is a completely different answer, and it's wrong. What you have to do instead is duplicate the complex number and then FOIL. So in other words, just like x squared is x times itself, the blob squared over here is going to be the blob times itself. And once you have it set up like this, then you have to FOIL. So let's go ahead and do that. First term for FOIL should give you 4. Outside term should give you negative 6i. Inside term should give you negative 6i. And then the final term, negative 3 times negative 3 is 9. And then I times I is I squared. And then simplify from here. 4 can't combine yet. Negative 6 and negative 6 combines to negative 12i. The I squared is negative 1. So 9 times negative 1 becomes negative 9. And give me a second. And then last, combine the real numbers, 4 and negative 9, to give you negative 5. And then minus 12i. And that would be the answer for that example. Again, do not distribute the power. Instead, take the blob, double it, and then FOIL. And you'll get the correct answer. And with that, you are officially ready for the online homework over 1.4 imaginary numbers. You all have a good night, and I will see you soon.